In this Learn With Me series, we will be going to learn about thermodynamics, basic concept. In chapter we will cover, what is the definitions of thermodynamics, system, surrounding and their types, thermodynamic properties and so on. Definition of thermodynamics. There are many definitions of thermodynamics that you can find from books or many websites. First thing I need to tell you about the word thermodynamic. The word thermodynamic is the combination of Greek words therma and dynamis. Therma means heat and dynamis means power. As is all known that power is associated with work. There are basically interaction between heat and work. First definition of thermodynamics says that thermodynamic is the branch of science which deals with the energy interaction, either work done on the system or work done by the system and what will be the impact on system, surrounding, and properties. Second definition of thermodynamics says that thermodynamic is the branch of science in which we study about 3E: energy, entropy, and equilibrium. Third definition of thermodynamics says that thermodynamic is the branch of science in which low-grade energy is converted into high-grade energy. Note: high-grade energy is work, and low-grade energy is heat. We can understand this by an example of mixer grinder. When we grind anything, the heat is generated that can we feel by touching the container, but we cannot utilize this heat to generate same amount of work. Now, we will study about system, surrounding, boundary and thermodynamic properties. What is system? Anything under consideration for observation or study is termed a system. There are three types of system: open system, closed system, and isolated system. In open system there are both mass and energy interaction takes place between system and surrounding. It is also known as flow system and control volume system. For example, IC engine, nozzle, diffuser, etc. In closed system only energy transfer takes place and mass remains constant. It is also known as control mass system and non-flow system. For example, IC engine without valves. In isolated system, neither energy transfer nor mass transfer takes place. It is impossible to a system to be completely isolated. For example, universe. Universe is the only system that we can consider as an isolated system. Thermal flask can be considered as an isolate system, but it is not completely an isolated system. What is surrounding? Anything outside of system is termed as surrounding. There are two types of surrounding: immediate and environment. The part of surrounding which is directly affected by the system is called immediate surrounding. The part of surrounding which is not affected by the system is called environment surrounding. Note: immediate and environment together forms surrounding. System and surrounding together forms universe. What is boundary? It is an imaginary line that separates system from surrounding. There are four types of boundary: real boundary, imaginary boundary, fixed boundary, movable boundary. Real boundary is always found in closed system. Real boundary is represented by continuous line and curve. Imaginary boundary is always found in open system. Imaginary boundary is represented by dotted line and curve. For fixed and movable boundary we can take an example of piston-cylinder arrangement. Piston is considered as movable boundary and body of cylinder is considered as fixed boundary. Note: boundary has no mass and zero thickness. Thermodynamics properties. The characteristics of the system is described by thermodynamic properties. There are two types of thermodynamic properties: intensive properties and extensive properties. The properties which are independent of mass is called intensive properties. For example, density and specific heat, etc. The properties which are dependent on mass is called extensive properties. For example, mass and potential energy, etc. Methods to identify the thermodynamic properties. There are following methods to identify the thermodynamic properties, whether it is intensive or extensive. Method 1. Let's consider a beaker of water having following thermodynamic properties: pressure, temperature, density, volume and mass. If we divide the water into two separate beakers, all the thermodynamic properties has been divided. The properties which are getting divided are termed as extensive properties. The properties which are not getting divided are termed as intensive properties. So here, volume and mass are extensive properties. And pressure, temperature and density are intensive properties. Method 2. If we divide extensive property by extensive property, we will get intensive property in result. For example, density is equal to mass by volume. Both mass and volume are extensive property. Hence density is an intensive property. Method 3. If a word specific is used with any thermodynamic properties, then the properties will be termed as an intensive properties. For example, potential energy is equal to mgh, which is an extensive property. If we say specific potential energy, then it will be equal to gh, which is an intensive property.